Hello, and welcome to our lesson on finding the scale factor by measuring enlargements of geometric figures. Today, we will enhance your understanding of how to manipulate and analyze shapes in geometry through the concept of scale factors. In this lesson, we'll delve into how to find the scale factor by measuring enlargements of geometric figures, applying this knowledge to various cases to cement your understanding and demonstrate its practical applications. So far, you have familiarized yourself with enlargement using positive scale factors, which increase the size of a figure while maintaining its shape. Enlargement using negative scale factors, which not only change the size, but also reflect it across a certain point. Enlargement using fractional scale factors, which reduce the size of a figure while still maintaining proportionality. With this solid foundation, we're now ready to explore how to quantitatively determine scale factors. This technique is crucial for various applications in geometry, such as resizing shapes in coordinate grids or solving real-world problems involving maps and models. Imagine you have a small sketch of an object and you need to create a larger version of it. Knowing how to find and apply the scale factor allows you to accurately enlarge or reduce the figure to your desired dimensions. Let's get started. Before we delve into finding the scale factor by measuring enlargements of geometric figures, let's recap some key definitions. Enlargement is a transformation that changes the size of a figure while maintaining its shape and proportionality. The scale factor is the ratio of the dimensions of the enlarged figure to the original figure. The center of enlargement is the fixed point from which the enlargement is made. Now let's break down the process of finding the scale factor. To find the scale factor, you need to identify corresponding points on the original and enlarged figures. Corresponding points are pairs of points that represent the same location on both figures. For instance, if point A on the original figure corresponds to point A prime on the enlarged figure, and point B on the original figure corresponds to point B prime on the enlarged figure, these are corresponding points. To measure the scale factor, we measure the lengths of corresponding sides on the original and enlarged figures. We then calculate the ratio of the two lengths by dividing the length of the side on the enlarged figure by the length of the corresponding side on the original figure. This will give you a ratio for each corresponding side. The ratio obtained for each corresponding side should be the same if the enlargement is consistent. This common ratio is the scale factor. Let's look at some detailed examples to illustrate this better. Let's start with a simple example to understand how to find the scale factor by measuring enlargements of geometric figures. Imagine you have a small triangle with sides 2 centimeters, 3 centimeters, and 4 centimeters. This triangle is then enlarged to a new triangle with sides 4 centimeters, 6 centimeters, and 8 centimeters. To find the scale factor, you compare the lengths of the corresponding sides of the original and enlarged triangles. Take one pair of corresponding sides, for instance, the sides measuring 4 centimeters and 8 centimeters. To find the scale factor, we divide the length of side in enlarged shape by the length of side in original shape. So the scale factor would be 8 centimeters divided by 4 centimeters. So the scale factor for this enlargement is 2. You can now double-check this by comparing the other sides. 6 centimeters divided by 3 centimeters equals 2, and 4 centimeters divided by 2 centimeters also equals 2. Now let's look at a rectangle. The original rectangle has dimensions 3 centimeters by 5 centimeters, and the enlarged rectangle has dimensions 9 centimeters by 15 centimeters. Again, find the scale factor by comparing the lengths of corresponding sides. So to find the scale factor, we do 9 centimeters divided by 3 centimeters. The scale factor is equal to 3. Verify this with the other pair of sides. 15 centimeters divided by 5 centimeters equals 3. So the scale factor here is 3. Consider a more complex shape such as a hexagon. Suppose the original hexagon has a side length of 2 centimeters and the enlarged hexagon has a side length of 6 centimeters. Use the side lengths to find the scale factor. The scale factor is equals to 6 centimeters divided by 2 centimeters, which gives us a scale factor of 3. This means each side of the enlarged hexagon is 3 times the length of each corresponding side in the original hexagon. As you can see, the actual shape and its complexity does not affect the process at all. In conclusion, to find the scale factor, you always compare the lengths of corresponding sides of the original and enlarged shapes. Measure carefully and ensure you are comparing the correct pairs of sides. This method works regardless of the complexity of the shape, as long as you correctly identify and measure the corresponding sides. In conclusion, to find the scale factor, you always compare the lengths of corresponding sides of the original and enlarged shapes. Measure carefully and ensure you are comparing the correct pairs of sides. This method works regardless of the complexity of the shape, as long as you correctly identify and measure the corresponding sides. In today's lesson, we explored the concept of finding the scale factor by measuring enlargements of geometric figures. We began by recapping some enlargement terminology. We then examined how to measure the lengths of sides in both the original figure and its enlargement to determine the scale factor. By working through various examples, we identified that the scale factor can be calculated by dividing the length of a side in the enlargement by the corresponding length in the original figure. Throughout the lesson, we emphasized the importance of accuracy in measurement and the consistency of the scale factor across all corresponding sides of the figures. By understanding and utilizing the scale factor, we can effectively solve problems involving geometric enlargements and ensure precise proportional relationships in various applications.